we have in this chapter, we will introduce the difference between streamlines, pathlines, and streaklines. And also we will introduce how to find the total derivative of a certain vector. So these are the main two important ideas in this chapter. And in the last section, section of chapter 4 will introduce the Reynolds transport theorem. And this theorem is of high importance because it is the main theorem that will be used in chapter 5. So if you want, this chapter will be just an introduction for chapter 5. Okay? Now, we will solve for this chapter the problems concerning streamlines and pathlines and the derivative of a vector. And then in chapter 5, we will do the applications for the Reynolds transport theorem. This is why this chapter is short, so we might finish it in 1 or maximum 2 sessions. So let us start with a first example. Streamlines for a given velocity field. We want to find in this problem, we have a 2D flow, which is steady, and the equation of the flow is given by V equal to V0 over L times minus xi plus yj. Okay? Now, when we want to find the streamlines, we should go back to the definition. What is the definition of a streamline? At any instant, if I take a picture of the flow, the streamline will be the line joining the velocity vector. So if you draw the velocity vectors on the path, they are tangent to the path. So if you draw the path, you will get the streamline. So it's just the streamline is defined as the line that is tangent to the velocity vectors of a flow field at a certain instant of time. Okay? This is why mathematically, to find the streamline, the equation is the following. You have that dy over dx is equal to v over u, okay? Where v and u represent the velocity components along x and y. So if you have a flow field, you have the flow field is defined by u, v, and w, which represents the component of velocity vector. Okay, so here, because it's a 2D flow, then we have only u and v, and w is 0. And to find the streamline, by definition, as we said, the streamline is the line that is tangent to the velocity vectors. So we can say that the slope of the streamline dy by dx is equal to the slope of the velocity, which is v over u. Okay, so for example, in this problem, we have the velocity vector is given by v0l times minus yi plus xj. Okay, so if I want to apply here, I have that dy over dx so in my problem here, if I look at the expression of velocity, I can say that u is equal to minus x times v0 over L, and v is equal to plus y times v0 over L. Okay, so now I can find the expression for my streamline. I just replace. Okay, so I deduce. So dy over dx is equal to minus y over x. Okay, and now to solve, you do separation of variables. So if I do separation of variables, by separating my variables, we get that dy over dy times dy over y equals to minus dx over x. And now you can perform integration in order to find the expression of y. If you integrate, so by integration, you get that ln y is equal to minus ln of x plus constant. Okay, so this is the equation of your streamlines. You can have you have several values. C can take any value, it's a constant. So by giving a certain value to C, you can draw your curves. Okay, so here if we take plus ln, if you take ln x to the other side, you can write that ln of x times y equals to a constant, to another constant, of course, to a constant c. Okay, and so x times y equal to a constant c2. Okay, so this is your equation, and now you can take any value for c and you draw the streamlines. So in this case, if you do your drawing, you will see this. Now, since this velocity field is steady, because it's independent of time, because the velocity field is independent of time, so anytime you take your picture, okay, so if you take a picture anytime, you will get the same graph, okay, because it's a steady application. If you have a transient application, the picture you take will depend on time, so the streamlines will vary. But because here your flow is steady state, at any time you take the picture, you will get the same figure. Okay. Now, what can change is if you want to know the direction of your flow, it will depend on V0 over L. So, for example, if V0 is positive, then you will have a negative x component and a positive y component from this side. So here, if you take the first quadrant, for the first quadrant, x and y are positive. So if you go to your expression of velocity, along x you have minus x v0 over L, and along y it's plus y v0 over L. So if v0 is positive, you can say that for the first quadrant, Vx is negative and Vy is positive. This is why the arrow here, as you can see, your arrows are going up, because you are moving along when your velocity has a negative x component anywhere and a positive y component. So you can see here this, like this. So this is the x component, this is the y component. Everywhere you have negative x component, positive y component. Now, if V0 was negative, if you take the same value of V0 but negative, what will only change is the arrows. So your arrows will be downward, but you will have the same streamline. Okay? So the streamlines will not purely define the flow. You need another information. Okay? Because if V0 is positive or V0 is negative, you will get the same streamlines. But what will change is the flow direction. Okay? Any question for this problem? Okay. So let me now move to another problem. In this problem, we will do a comparison of streamlines, pathlines, and streaklines. And I have posted for you a YouTube video showing the difference between these three. So if you didn't watch it, please watch it, because it will help you to understand what is the difference between the three. Now we will do a numerical example to study the difference between the three. I will open a new file because here it is not very clear. I posted this file for you. Okay, so here you can see it's more clear here. Okay. Do you see the file now?
Yes.
Okay. So we give a flow given by, the velocity field is given by v equals to u0 sine omega t minus y over v0 along I and plus v0 along j. And we want where u0, v0, and w are constants. And as you can see here, you have time. So in the previous example we did, we don't have time. So it's a steady state application. In this example here, we have variation with time. So it's a transient flow field. And for this flow field, you will see that when you have transient applications, the streamlines, pathline, and streaklines will be different. However, in steady state application, if you draw the streamlines, pathlines, and streaklines, they will be the same lines. Okay, so the main difference between the three will be observed when you have transient application. Now, what they want us to find, determine the streamline that passes through the origin at t equals 0 and at t equal pi over 2 omega. And the second question is to determine the path line of the particle that was at the origin at t equals 0 and at t equal to pi over 2. Now, we will explain in this problem mainly the difference between streamline, pathline, and streakline. To begin with, to find the streamline equation, as we did in the previous problem, okay, we have the equation of velocity field. We have it here. So we have u is equal to u0 sine omega times t minus y over v0, while v is constant equal to v0. Okay, so to find the streamline equations, we need to do dy over dx equal to v over u. Okay, and v is equal to v0, while u component is u0 sine omega t minus y over v0. Once you write this equation, what is the next step? In order to find the expression of your streamlines, you do separation of variables. Okay, so here I do, the second step is to do separation of variables. And pay attention, when you find your streamlines, you consider that your variables are y and x, and t is just a parameter. The time will be a parameter. Okay, so now when we will do separation of variables, what do we get? We have from this side along x no variable here. You can no variable along x. You have a variable only along y here. Okay, so you have y from this side. This is why we will take it to the side of dy. So you can write that u0 times sine times omega t minus y over v0. Okay, this is from the side of dy equals to v0 dx. And now after doing separation of variables, we can integrate. So now by integration, as I said, when you integrate in the first side, you integrate with respect to y. So you consider that t is a parameter. Okay, so if we do the integration here, you know that the integral of sine function is minus cosine. Okay, but here, because you have a function of y, so you have minus omega y over v0. You know that to perform the integration, you need to appear the derivative of this term. Okay, so from calculus, what you should do, you should multiply, when you do integration, you should multiply by minus v0 over w. Okay, this is why when you perform the integration, you will get u0 times, and as we said, integration of sine is minus cosine, but I will multiply by minus v0 over w, so I get plus v0 over w. So now I obtain u0 times V0 over omega, okay, times cosine of my function, okay, my function which is omega times t minus y over V0, okay, and of course when I do integration I can add a constant, okay, because if you want you can lump the two constant in one side, because if you do from the first side, for example, plus C1 and from the other side plus C2, you can lump the constants together. So from the other side, if I integrate, I get V0x, because V0 is a constant, so I get V0x plus C2. If you take the two constants together, you will end up with the following relation, that after integration, I did use that. This is the equation of my streamline, okay? So this is an equation relating x and y. And as you can deduce, t is a parameter in this equation. So for each time t, you have a new streamline. This is why we say that streamlines are like, they take a picture of the flow field at a certain instant. So because it's a transient application, for each time t, you can get a new series of streamlines. Okay. Now, in particular, they asked in the problem to find the streamline at t equals 0 that passes through the origin x equal y equals 0. Okay. So if you want to find this streamline, you will use the boundary condition given. So our purpose is find the streamline that passed through the origin, at t equal 0. So the first step is I want to find the streamline at t equals 0. Okay. For the streamline at t equals 0 can be obtained by just replacing the parameter t by 0. Okay. So what is the equation of the streamline? It is u0 times V0 over omega times cosine of omega y over V0, because we replace t by its value, which is 0. Okay, so cosine minus omega y over V0. Now you know that cosine alpha is equal to cosine minus alpha, so you can replace it by just cosine omega y over V0. Okay, and we have from the other side equals to V0x plus constant. Okay, now how to find the constant? In order to find our constant, we will apply the condition, the boundary condition, that we want the streamline passing by the origin. Okay, so if we want to find the streamline passing by the origin, we say that for x equal to 0, y equals to 0. So replacing back in our equation, okay, we have that u0 v0 over w. Now if we replace by y by 0, we get cosine of 0. Cosine of 0 is 1. Okay, equals to, from the second side, x is 0, so we get c. Okay, so we get that for the streamline passing through the origin at t equals 0, the value of the constant c is u0 v0 over w. Okay, so now if we replace back into our equation, we can get the equation of the streamline at this instant. Okay, so replacing c by its value, we get the new equation. This equation is for the streamline that passes through the origin at t equals 0, and you will obtain this form when you replace. you will obtain that x is equal to v0 over w, if you take it into common, times cosine wy over v0 minus 1. Okay, now for the next step, we will find another streamline, because they asked for the streamline that passes through the origin at t equals 0, and they asked also for
دكتور
yes.
بس حطينا u0 v0 over w equals c، شو عملنا بس؟
عملنا بدنا نلاقي الكونستنت. مظبوط. You want to find what is the constant c. To find the constant c,
okay, جبنا constant x equals 0 y equals 0.
مظبوط. You replace it بس in the equation and you are done.
Okay.
Okay.
We'll see.
يعني first they told you you want the streamline at t equals 0, you replace t by 0. Now you still need to find what is c. To find c, you replace by the boundary condition, which is x equal y equal 0 at this time. Okay, so once you replace, you get what is the value of c, and then you get the equation of your streamline, which correspond to the streamline that passed by the origin at t equals 0. Okay. Yeah, we will repeat it now in another example here, so you can see it another time. The other question is to find the streamline that passed by the origin at t equal pi over 2 omega. Okay, so here this is another streamline, because we said here that it's a transient application. This is why the streamline passing by the origin will vary with time. Okay, so if we want to know what is the streamline that passed through the origin at t equal pi over 2 omega, what should we do? The first step, we replace in our equation t by pi over 2 omega. Okay, so let us do it. So first step here, step 1, okay, we replace in the second question, we replace t by pi over 2 omega. Okay, if I replace t by pi over 2 omega in my equation, I get the following. I get u0 times v0 over w times cosine. Now I just replace t by the value they want. Okay, they want the streamline for t equal pi over 2 omega. So I have omega times, I replace t by its value, which is pi over 2 omega, and it's minus y over v0. Okay, and then this is equal to equals to v0x plus a constant. Okay, I will call it C3 if you want to not confuse the constants. Okay, if I want to find the constant now, I will use the boundary condition. What was the boundary condition they gave me? They said this streamline passed by the origin. Okay, passed by the origin. So I can say, so for x equals to 0, y equals to 0. Okay, now if I replace into my equation by x0 and y by 0, I get that u0 v0 over omega. Okay, now you have y is equal to 0, and you still have only cosine omega pi over 2 omega. Omega will be simplified. Okay, so you have cosine pi over 2, which is cosine, so times cosine 90 degrees. Okay, cosine pi over 2 will give you what? Cosine 90 is 0. Okay, so this term will cancel, equal from the other side to v0 times 0, which is 0 plus C3. So we can deduce that for this streamline, the value of the constant is 0. Okay, so now you got the streamline equation that passed by the origin for t equal to pi over 2 omega. You get the following equation. And as you can see here, the streamline that passed through the origin at t equal pi over 2 omega is different than the streamline that passed through the origin at t equals 0. And this is due to the transient process. Okay? Any question on this? Now, for the next question, we want to find the Pathline equations. Okay? What is the difference between streamline and Pathline? It's the definition. We said that the streamline will join the velocity, if you want, is always tangent to the velocity field. However, the definition of Pathline, the Pathline will follow a certain particle with time. Okay? And so instead of taking a picture, if you take a picture of your flow field, you see streamlines. If you follow a particle with time, you get the path line. Okay? So in this case, you can track a particle with time. So you want to find x function of t and y function of t. And in order to know what is the equation of the path line, you eliminate t between x and y. Okay? So for this example, as we said, your purpose to find the path line is to get x function of time first and y function of time. To do this, you go back to the definition of the velocity. The definition of the velocity is the derivative of position. This is why you can say that v of x, the component of velocity in x, is equal to dx by dt. Okay? And in this flow field, the x component is equal to the component along I, which is u0 sine omega t minus y over v0, while vy is constant, is equal to v0. Okay? So this is v of y. Now, since
دكتور
you
بس
know...
ما فهمت شو عم نعمل نحن هلا.
اوكي. نحن هلا بتاني سؤال. أول سؤال كان find the streamline. Now we want to find the path line. Okay? What is the difference between the streamline and the path line? I will go back to the given to tell you what they want. In part A, the question was to find the streamline that passed through the origin at two different times, t0 and pi over 2 omega. And this is what we have done together, okay, until now. The second question is to find the path line of the flow field for the case of t0 and t equal pi over 2. Okay, so the question here is different from the previous one, because when you have unsteady flow, the streamline is different than the path line. So we will see, and we will see together now when we derive the equation of the path line of the particle that was at the origin at t equals 0 and at t equal pi over 2. The equations will be different than the streamlines at t equals 0 and at t equal pi over 2 omega. Okay? Because as we said, because it's a transient flow, the streamlines are different than the path lines. Okay? In the first question, we have found what are the streamlines equation passing by the origin at t equals 0 and at t equal to pi over 2 omega. Now we will repeat the same work, but to find path lines. Okay? And to find path lines, you should go back to the definition of a path line. The definition of a path line is it's a line that follows the particle. So it will track its position with time. This is why if you want to find the equation of a path line, you will need to find x function of t, y function of t, and then you eliminate time between the two. Okay? And to do this, since you have the velocity field equation, you can say that Vx of the flow field represents dx by dt, and Vy of the flow field represents dy by dt. Okay? Since you know Vx and Vy of your flow field, if you integrate with respect to time, you can get x function of t and y function of t. This is what we will do. To start by x, we said that Vx is u0 sine omega t minus y over v0. This is by given, because the given gives you the expression of the velocity field. So you have x and y component. This is the x component of v. and this is the y component of v. Okay, so now since you know these components, you can integrate to find what is x function of time and what is y function of time. To start by the first equation to get x. Okay, if you integrate this equation with respect to time, so integrate with respect to t with respect to time, what do we get if we integrate with respect to time? We have the integration of dx over dt is x. Okay, so I obtain that x is equal to, now if I integrate this term with respect to time, I get what? What do I get? The integration of sine omega t is what? It's minus cosine over, and I should divide by what? I should divide by omega. Okay, so x is minus u0 over omega, okay, times cosine of omega times t minus y over d0. Okay, is this true what I did? Is this true? Who will tell me if this is true or not? Why what I did is not true? Who will tell me?
Amilna with respect to y instead?
Yeah, no, because we have y in this equation, and y is a function of time. It's a function of time. So what is the first step to do before doing integration here of to find x? I should find y with respect to time. Okay, so I cannot do this. Why is this wrong? So this is wrong because y is a function of time. Okay, it's not a parameter here, y. It's not a parameter that is varying. No, it's a function of time. So this is the difference between this case and the previous one. In the previous one, when you integrate with respect to x and y, t is a parameter. T is not function of x and it's not function of y. X is function of t and y is function of t. Okay, so here, because in your expression of the x you have y, the first step you should do is to find y function of time and then replace. Okay, this is why, as we said, we will not start by finding x, we will start by finding y. For y it's simple because dy by dt is constant equal to v0. So from this relation, if we integrate y with respect to time, so if we integrate this relation with respect to t, what do we get? From the first side, you have dy by dt, so the integration is y equals to, for the other side, it's v0t plus a constant. I will call it c1. Okay? So this is my first integration will give me y. So this is the equation, let's say 1. Now, what I will do, I should substitute y by its expression in dx by dt, and then I can integrate with respect to time. Okay, so now if I replace y by its value in this expression, so replace in x, I get that dx by dt is equal to u0 times sine of omega times t minus, I will replace y by its expression, which is v0t plus c1, and since I should divide by v0, so I will get minus t. Okay, so I get minus t and plus c1 over v0. Okay, so now you can see here that t will cancel out because you have t minus t. Okay, so you did use that dx by dt is equal to u0. So here, don't forget you have a minus outside, so it's minus c1, okay? Because you have a minus outside of y over v0. So you get u0 times sine of minus omega c1 over v0. And if you want to take the minus out, because you know that sine alpha is equal to minus sine minus alpha, okay? So you can say that it's equal to minus u0 times sine c1 times omega over v0, okay? So now,
دكتور
yes,
ما فهمت ليه ما عملنا هيك كمان فوق.
when for okay for t is a parameter. Is t function of position or it's a chronological parameter? يعني انت if you, what is depending on what? X and y depends on t, or t depends on x and y?
X and Y depend on T.
Very good. So when you integrate with respect to x, or when you integrate with respect to y, t is a parameter. It's not a function of x and y. You can treat it as a constant when you integrate. However, here y and x are function of time. So if you have y in an equation and you integrate with respect to time, you cannot consider that it's a constant, because it's a function of time. So what you should do, you should find y as a function of time, then you replace it into your equation, and then you can integrate. Okay? So here you
Okay,
cannot
doctor.
integrate and consider that y is constant. No, because y is function of t. It's not a variable parameter like time. It's a function of time. Okay? This is why when you want to integrate the first relation with respect to t, you should first replace y by its function. And y, you can get it from the second relation. Since dy by dt is a constant, you can replace y by v0t plus c1. Replacing back into the equation, you will get then dx by dt. And as you can see, when you replace, dx by dt is independent of time now. So it's a